Hi and welcome to Standard 14. Standard 14 is interesting. We only do one thing. We prove the Pythagorean theorem. So let's read it. Standard 14, students, prove the Pythagorean theorem. That's all it says. And Standard 14, as you can see, there's only one problem. Problem 60. Okay, let's look at it. This one is a bit complex. A diagram from a proof of the Pythagorean theorem is pictured below. So there it is. Which statement would not be used in the proof of the Pythagorean theorem? Alright, so it has four different statements. I think the best way to do it is to do the proof ourselves. So if I look at this, first thing I know is that the big square is equal to the small square plus the four triangles. Okay, you can see that? The big square is equal to the small square plus the four triangles. So now let's do a little math here. The side length of the big square is a plus b. So that's going to be a plus b squared. That's the big square. Is equal to the small square, whose side length is c. So that's going to be c squared plus the four triangles. And the triangles have one side that is a, one side that is b. Therefore, it's going to be four of them times ab over 2. The reason it's ab over 2 is because it's base times height divided by 2. Alright, so now we're going to FOIL this out. We've got a plus b squared. So a times a is a squared. A times b is ab plus a times b, which is ab again, plus b squared. And that's our FOIL. So a squared plus ab plus b squared is the area of the big square. And that's going to be equal to c squared plus, we'll do the distributive property here, 4ab over 2 is going to equal 2ab. Okay, so we've got a squared plus ab plus b squared equals c squared plus 2ab. Now notice here we've got ab plus ab. When we combine these two, we get another 2ab. So we can rewrite as a squared plus 2ab plus b squared equals c squared plus 2ab. And what you're going to notice is that if we have 2ab here and 2ab here, we can subtract it out, and the last thing it's going to give us is a squared plus b squared equals c squared, the proof of the Pythagorean theorem. So let's look at what our choices are. Do we need to know that the area of a triangle equals 1/2 AB? We certainly do, because we use it right there. So that can't be the answer, because we're looking for the thing that is not used. Do we need to know that the four right triangles are congruent? We certainly do, because we're multiplying by 4. If they weren't congruent, we would not be able to do that. Do we need to know that the area of the inner square is equal to half the area of the largest square? Well, it never exactly says that. It says that the area of the inner square plus the four triangles is equal to the area of the largest square, but it never says that this is half of this. So that sounds a little fishy. I'm going to hold that out there. And then D, the area of the largest square is equal to the sum of the areas of the smaller square and the four right triangles. Well, that is our starting statement. So that we definitely used. So the one we did not use, was C, which says the area of the inner square is equal to half the area of the largest square. We did not use that. Okay, that's Standard 14. Go slow, rewind if you need to, and good luck with it. And I'll see you in Standard 15. Thanks.